Welcome to a video on solving basic absolute value equations. In this video, we're going to look at understanding equations that can be written in the form absolute value of x is equal to a. Let's get started. Let's start by looking at the different types of solutions these equations can have. Most absolute value equations have two solutions. For any real number x with a greater than 0, the equation absolute value of x equals a has the solution x equals a or x equals negative a. So there are two solutions. You might be wondering, why are there two solutions? The absolute value of x describes the distance between the value x and the number 0 on the number line. In most cases, there will always be two values that are the same distance from 0. For example, let's look at the equation the absolute value of x is equal to 3. On a number line, we're looking for values of x that are a distance of 3 units from 0. This would be like the number 3. 3 is 3 units from 0. And also negative 3 is 3 units from 0, but in the opposite direction. So in this case, the solution to this equation is x equals 3 and x equals negative 3. There are cases where the equation will only have one solution. For any real number x with a being equal to 0, the equation absolute value of x equals 0 has a solution x equals 0 only. Why only one solution? Well, it goes back to the absolute value of x describing the distance between the value x and the number 0 on the number line. There is only one value that is 0 units away from 0, and that is 0. So for example, if you're trying to solve the equation, the absolute value of x equals 0, on the number line, you're looking for a number that is 0 units away from 0. That can only be the number 0. So your solution in this case is x equals 0. And finally, there are absolute value equations with no solution. For any real number x with a less than 0, the equation absolute value of x equals a has no solution. You might be thinking this looks exactly like the equation from a previous slide. Why does this not have a solution? This one has no solution because in this case, a is less than 0 or negative. So I think a better way to rewrite this statement would be if you end up with the equation absolute value of x equals a negative number, there is no solution. Why no solution? Well, it goes back to the fact that the absolute value always describes the distance between x and the number 0 on the number line. Since distance cannot be negative, the absolute value of a number will never be negative. For example, for the equation absolute value of x equals negative 3, you would be looking for a value of x that is a distance negative 3 from 0. Since distance is always a positive quantity, this cannot happen, so this equation has no solution. Now that we've covered the types of solutions these equations may have, let's look at the steps to solve absolute value equations. As we do this, we'll solve the problem 4 times the absolute value of x plus 9 is equal to 17. The first step is to isolate the absolute value expression. You want to get the equation in the form absolute value of x equals a, where a is some number. Let's go back to our equation. We need to isolate the absolute value of x. The first thing that we need to do is to subtract 9 to both sides. This will give us 4 times the absolute value of x is equal to 8. One more step to isolate the absolute value of x, we need to divide both sides by 4, and this will give us the absolute value of x is equal to 2. Once you've isolated the absolute value, check the value of a. As we just covered, if a is less than 0 or negative, the equation has no solution. If a equals 0, the equation has one solution, x equals 0, and if a is greater than 0, the equation has two solutions. In this case, our value of a is positive 2, so we know that this equation will have two solutions. The third step is to rewrite the absolute value equation as two sub-equations, x equals a or x equals negative a. For this problem, we would end up with x equals 2 or x equals negative 2. Step 4 would be to solve the resulting equations. Now, in our problem, x is already isolated, x equals 2 or x equals negative 2. However, there may be other problems where you have to continue to isolate x. I have a separate video that covers those equations. The last step would be to check your answers in the original problem. Let's go ahead and check x equals 2. Plugging 2 into our original equation, we would have 4 times the absolute value of 2 plus 9 is equal to 17. In this case, the absolute value of 2 is 2, so we would have 4 times 2 plus 9. We want to see, is that equal to 17? 4 times 2 is 8. 8 plus 9 is in fact 17, so this does work. 2 is a solution to our original equation. Now let's check x equals negative 2. Let's plug that into the original equation. This would give us 4 times the absolute value of negative 2 plus 9 is equal to 17. The absolute value of negative 2 is 2. So once again, this would be 4 times 2 plus 9. Is that equal to 17? Once again, we end up with 8 plus 9 is equal to 17. That does check out. That is true. So we know x equals negative 2 is a solution to our equation. Okay, let's take a look at a few more examples. Let's solve the equation negative 8 times the absolute value of x minus 3 is equal to negative 43. The first thing we need to do is to isolate the absolute value of x. Let's add 3 to both sides. This will leave us with negative 8 times the absolute value of x is equal to negative 40. Dividing both sides by negative 8, we'll end up with absolute value of x is equal to 5. Okay, we've isolated the absolute value of x. Let's check the value of a. In this case, a is 5, which is positive. This tells us that we have two solutions, x equals 5 or x equals negative 5. These equations are already solved for x, so there's nothing left to do except check. I will leave it to you to check these problems, but they do in fact work in the original equation. Now let's solve the equation 6 times the absolute value of x plus 14 is equal to 14. Let's start by isolating the absolute value of x. To do this, we'll need to subtract 14 to both sides. So we get 6 times the absolute value of x equals 0. Dividing both sides by 6, we get the absolute value of x equals 0. In this case, our value of a is 0. So this equation only has one solution, and it's x equals 0. The last thing to do would be to check, and I'll leave that to you, but in fact, x equals 0 is the solution that works for this problem. And finally, let's solve the problem 5 times the absolute value of x plus 12 is equal to negative 18. The first thing we need to do is to isolate the absolute value of x. To do this, we'll start by subtracting 12 to both sides. That leaves us with 5 times the absolute value of x is equal to negative 30. Dividing both sides by 5, we get the absolute value of x is equal to negative 6. It looks like a is equal to negative 6 in this problem. Since a is negative, and we know the absolute value of x can never be equal to a negative number, we know that this equation has no solution. That's it for this video. Thanks for watching.